Well, thank you everybody for joining this session and see what Robin has to say about OFTA. We're going to start by a poll question and encourage you to respond to this poll. This first poll is a question on what you are in this in this industry or what your practice is. So I'll give you a second to answer this. These questions are important to us, and if you answer and let us know, then we know that we're reaching the right audience or not reaching the right audience. Very important to us. So thank you for answering the poll. I'll just give you a few seconds to do that.
We'll have those results in about 15 seconds.
Okay, thanks. A lot of people are better on computers than I am. If you could do everybody answers all those polls in a few seconds. Yeah, this is poll question number 2. The first poll was about the location. So we've got a pretty good mix here. The questions show that we're nearly even, except there's not many owners, but we know that anyway. But other than that, we've got a real good mix of contractors, consultants, and designers. So thanks for answering that poll. Now we're going to roll to the next question, if I can get out of this poll. Okay. Now, of course, OFTA. What is OFTA, and why is OFTA important now? And OFTA, of course, is something that Robin's coined. We just wanted to shorten up the whole term OFTA because it means Onsite First Time Assembly, and that's a mouthful, so we just shortened it up to OFTA. We're going to give you some case histories where we've used it successfully. We're going to answer some questions in here about problems that we've had, which aren't really that many. And we're going to tell you what we've learned through the OFTA process. On-site first-time assembly, what that really means is what happens in this process, the components are assembled on in the workshop or in the subcontractor's shop, and they're tested out there. Then they just go from there directly to the site, and then we fit them together the first time at the site. There's no shop assembly in total assembly in a workshop before that. This on-site assembly is just like it is when the assembly is done in the workshop. Everything comes together, and we put this thing into operation just as if it was in the workshop. Of course, the traditional way to do it is, as you see here on the screen, is a big workshop. This is one of our workshops in Ohio. Here we have 2 or 3 machines under final assembly. And this was more or less traditional up to about 3 or 4 years ago. And make no mistake, we certainly do a lot of full shop assembly ourselves. We have about 5 or more than 5, about 10 machines in shop assembly process right now in our various workshops around the world. That's still the most common way to do it, is total assembly. What we're presenting here is an option. And under the full shop assembly, what's also interesting is you can't really do load testing. Obviously, you can't test the gripping functions, the torque functions as associated to the cutter head, the drilling functions. There's lots and lots of functions you can't test because you're in a shop environment and you can't put load on the machine. So normally in a traditional delivery, there's a shop test, and then there's another sign-off field test. And usually there's even a third one called the 300 or 500 meter test. So in a traditional thing, those tests are usually written into a contract. What we're doing with OFTA is really eliminating the first sign-off. It goes directly to the sign-off in the field test. And of course, when a traditional delivery, after we've done all this testing, taking us months to put this machine together, then we got to disassemble it, and we disassemble it into components that are the same, essentially, components that we have for OFTA. These components, of course, the limitation on these components is shipping size. So we have to disassemble this machine and make sure it's in sizes that can be transported either by road or ship or etc. And why would OFTA be interesting for any of the operators and contractors? And the reason it's interesting is, of course, we're reducing time. And in most cases, we think we knock off about 2 to 5 months from the time the order is placed for the TBM to the time of start of boarding. And the time of start of boarding is, of course, the critical criteria here. The operator wants to board. And I should say, really, the most critical criteria is the time to get through the learning curve, and that means debugging the machine. And what we're looking here is to reduce time and cost. I mean, certainly we reduce the cost. That is obvious. We don't have to put the whole machine together in the workshop. We don't have to break the machine apart. And so we save the labor. And we're saving a lot of shipping costs. We don't ship all components into a factory and turn around and ship it back out of the factory to the final destination. And, of course, the idea is to pass these savings along to the contractor. And although we'd like to maintain them, being fair business partners, we pass them too. And it has helped the contractors, and it certainly helps the project schedule. And the other benefit that comes out of this is that we send out a much larger crew than we would normally send out, and this crew is effectively a training crew, and they train the contractors' personnel right on site. Everything's live, and another big benefit is that this knowledge is retained. You don't 2 or 3 months doesn't transpire between shop testing and training to the actual use of the knowledge. You put the machine together, you test it, you load test it, and the crew's with you all the way, and then you start the board, and it's just like a hands-off in a good marathon. It's a really nice way to train the people and get them integrated into the working processes of the machine. Just a little bit on timing. I mean, why are we pushing OFTA, and why now? Well, we're kind of an old business. We're 60 years old. Our company putting TBMs together for 60 years. We've learned a few things over that time period. And so it's what we consider a mature product now. And we've actually put together ourselves probably not several hundreds. I mean, I think the whole industry is up into several thousands of machines put together. And so it's not such a unique product or a unique process putting these machines together. And the other thing that our industry and us and our competitors, we've sort of evolved into standard components. And we've got a lot of standard drives, a lot of standard bearing and seal assemblies, and we keep repeating these just because they work well and it's good for cost-effective production. So these are standard components. We know they go together. We know how they go together. So it's not far-fetched to see them going together in the field. And it's a repetitious process. Another big contributor is the advent of CAD drawing. If most people understand and see CAD, we do it in our presentations when we go to shows. These are these nice, as you see on the left side, nice three-dimensional drawings. And what's interesting about CAD, of course, you can fit pieces to pieces and see if it works in the drawing. And then if it works in the drawing, and if your machining is correct, then of course it'll work in the machining. And so we can test these fit-ups. And the other thing about CAD is you actually design the whole machine before you start releasing the components. In the previous history, when there wasn't CAD and just two-dimensional drawings, various parts of the machine were designed concurrently and not done from the top down. And with the top-down design, it leads to much easier and less fit-up problems. And, of course, this is just a shot of part of the machine being assembled. And these are the key components. This is where the main bearing is. Gearboxes go together here. And all these critical parts are fitted up first. So there's a lot of fitting up and of the key areas, reducing the possibility of problems. And of course, there's modern technology today. Not only is there CAD 3D, there's these new CMM machines that are really even better than fit-up. They're portable, really optical machines that go in and test the fit-up. And these are very, very accurate machines, and we're starting to use them more and more. You can just check them against the drawings. You can check them against other fits. And with these tools, you can really pick up errors. Simply, you can check out a whole big section in a couple of days where if you have to shop fit and you have a problem, it's really inefficient to take it apart and do rework. With these tools, you can pick up the problems and you don't have to go through all the trouble actually mating the pieces. And, of course, the other big thing with this program is that you have to really plan well for it. You have to plan well for any TDM assembly. It's a lot of pieces arriving at the site and a lot of pieces going together. And the best way is to do it in a sequential manner or just on time delivery. And that we use with this OFTA very much. In a lot of cases, the project doesn't want to see a whole machine arrive anywhere near his site. All he wants to do is get his pieces as he needs them, especially on a shaft project. So he'd like to see the cutter head support arrive one day, and 3 days later the gearboxes arrive so we can put them in, and then a week later the cutter head arrived, and it's an organized sequencing. And that's what that's one of our goals in getting this sequencing down. It's also complicated even from if we do complete assembly, we have to do that, but it's also done here in OFTA. And we've got quite a few good teams now, experienced teams of technicians, electricians, hydraulic specialists that go out to these sites and just help work with the local contractors and put these machines together. Got a poll question here, and this poll question, of course, is about what's your experience of putting a machine together, both in the workshop and on site. And while you're going over this question, I'll just do the general question if we've got one, Brianna.
Yes, we do have two, actually, of the same question. The question is, can you provide a rough estimate of the cost savings? And I'm going to actually further this question by saying, suppose you have a 10-meter machine that costs $20 million US for the machine itself and another $5 million US to assemble and ship. How much would the cost savings be in a case such as this?
Yeah, that's a common question. What do you really save? Certainly, you save on shop assembly, and we generally save on a 10-meter machine. We'd be saving nearly 15,000 to 20,000 labor hours. If you equate that into $50 an hour, you're saving $1 million, or $50 or $60 an hour, you're saving $1 million there. And we usually say we save about 2/3 of or 1/3 of the shipping cost. So if it's a $5 million shipping cost, you're saving $2 million. So the answer is approximately $3 million. That's what you'd save on. That'd be the difference. So it'd be $25 million with a first shop assembly, and it'd be somewhere around $22 million with an OFTA assembly. I think we're okay with the polls. There's a lot of people that half the people have never put a machine together. So hey, I'm home free. I'm talking to the people that haven't, that are not going to give me any heavy questions here. Okay. I'm going to run through some case histories here, and these one of the